Hi, I'm Jay Harkins from Kimble Chase. We make reusable glassware, laboratory glassware, and today I want to talk to you about breaking glassware, and I'll do a little demonstration of glassware breakage and talk to you a little bit about safety in the lab and the different types of glassware we have. So let me start by just talking about the glassware types and what we commonly find in our lab. And mainly what I want to talk about today is this sort of glassware. This is a borosilicate glassware that is reusable, and we have graduated cylinders, volumetric flasks, different types of glassware used for different applications. Borosilicate glass, we make things according to ASTM, and ASTM specification E438, Class A Type 1, defines the borosilicate type of glassware, and that's mainly what you find for the majority of laboratory glassware. The jars, jugs, some bottles could be made of soda lime, so this does not have the thermal shock resistance like the borosilicate does. So make sure you select the right type of glass for your application. And these are great for storage. You don't necessarily want to put this on a hot plate or autoclave. It doesn't resist the thermal shock like the other types. If you're going to put media into the autoclave, use a media bottle. But in general, the reusable glassware is what I want to talk about today, and in terms of the glass breakage. There are some things that you can do for any glass before you use it. Make sure you inspect for flaws, cracks, checks, scratches. That's important that you inspect your glassware before you use it, just to keep everyone safe. And if you see flaws and cracks, things like that, you definitely want to take it out of service and be conscious of how you're using the glassware. That's kind of the whole reason we're doing this little demonstration, is to think about, get you to think about how you use the glassware. In general, things that like volumetric ware is not going to have as hard of a life as something like a beaker or an Erlenmeyer flask, just because we don't put these on a hot plate as much as we do with these, or put stir bars in them, or these are used every day. So that's the sort of the take home from the video. But in terms of using the different types of glassware, the reusable are the main focus for today, and glass breakage. So these are new Erlenmeyer flasks. We pack these to protect them in cardboard with dividers, and we want these to give you a long service life. But I'm going to demonstrate how they can become fatigued and weakened. Initially they're perfectly fine for your everyday rugged use. But what I'll do is put these, I'm going to mimic what you would normally do in your laboratory, putting chemicals like normally powdered or crystalline salts, things like that. You put water and stir bar and your chemicals in there, and you turn on the stir plate and start dissolving your reagents. And over time you can have some abrasion and develop some weakness in the glassware. So after everyday use over a long period of time, you can weaken the glassware, even though you may not know that you're doing it. So let me just do this demonstration and see what happens here. So I'm just putting the safety glasses and gloves on, so please don't try this at home. We don't like broken glassware, and we want people to stay safe. So I'm just going to take this beaker with little shards of glass and swirl these around. So this is just to mimic what you would do with a stir bar, or cleaning it every day. If you use the bottle brushes with the wire that holds the bristles together, if you're too aggressive with those, the wire, if it contacts the glass, it can actually scratch. So be careful with the brushes, with the metal holding the bristles together. But I mean, this looks like a typically, a normal piece of glassware that you'd find on the shelf, but they look the same, so anyone would use this. It holds liquid. People would put it on a hot plate, but over time it's going to get weaker. So if we clink these together, chances are this one is going to fail instead of this one, but we'll see. Yep, sure enough, this one was weaker. So we have to think what happened with this. What weakened it? That was just glass swirling around for a few seconds in the flask, and it caused failure. We actually created some microfractures on the surface of the glass. And there was a guy in the 1920s called Alan Arnold Griffith, who described the brittle fracture of materials. He was actually a metals engineer, but the same principles apply for brittle materials. And he described this propagation of cracks into fractures from fairly low forces because of the brittle nature of these materials. And that's what happens. We have micro fractures, or Griffith flaws is what they're actually called, and relatively low forces can cause those to propagate and failure of the glassware. So it's important to think about how you use your glassware and what applications you're using it for, how long you've had it in service, and always inspect your glassware before you use it. Check for the cracks and the checks and imperfections in the glass, and if it has been in service for a long time, consider taking that out of service and replacing it. To get all the information your lab needs to handle glass safety, please contact your Kimble Chase representative to schedule a glassware safety seminar for your lab. Thanks again for your time.